Okay, good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. Our lesson today, I would like us to look at some of the features which are actually created as a result of chemical weathering. And those features that we are going to look at, they are mainly features associated with carbonation. Our previous lesson, we looked at what chemical weathering is, and we also looked at the 4 examples which comes under chemical weathering. And today, what I'd like us to be able to do is to be able to identify some of the landform features in reality that are actually created as a result of chemical weathering, mainly under the example of carbonation. But before we start off with the information on the different features which are created as a result of chemical weathering under carbonation, I'd like us to quickly recap and revise on what we have already looked at on the 4 examples of what comes under chemical weathering. Okay, definition first of all for chemical weathering. It is mainly the disintegration or decomposition of rocks caused by a chemical reaction. It's important that we are able to note that in chemical weathering there is a chemical reaction. There are 4 examples that we have looked at which comes under chemical weathering, and the 4 examples are solution, carbonation, oxidation, and hydrolysis. Yesterday we were able to, or our last lesson, we were able to look at the key areas or the key points that we were able to identify that should be able to help us differentiate between solution, carbonation, oxidation, and hydrolysis. Look at solution. Solution is the most important and also the most common initial phase of many weathering, chemical weathering processes. It is the process whereby a substance in the rock is dissolved either by rainwater or by other substances such as acids in the water. And here we also note that all minerals are soluble to some extent. Soluble meaning they will be able to dissolve. And all minerals, or some minerals like rock salts, they readily dissolve in water. Even quartz, which is also a mineral found in a lot of igneous rocks, is slowly dissolved, particularly in slightly alkaline waters at high temperatures. Okay, that is on solution, information that we have looked at. From the work on solution also, we note that limestone is insoluble in water. That means it will not dissolve in water, but when it reacts with carbonated waters to form the bicarbonates, which is soluble. And solution is actually highly significant weathering process because of its direct effects on rocks and also because of the reactions it initiates. We also looked at hydrolysis, and you did mention that hydrolysis is the main type of chemical weathering in which water combines with rock minerals to form an insoluble precipitate. We looked at an example, the clay minerals. Oxidation, we said that it is the combination of minerals such as iron and iron compounds with oxygen, and this reaction takes place most easily in the presence of water and heat. An example we looked at was rusting of metal objects. And finally, the work on carbonation that we looked at in our previous lesson. This is the reaction of certain minerals such as calcium, magnesium, and sodium with carbon dioxide. Water and carbon dioxide combined would form a carbonic acid, which then attacks many rock minerals. Still on the work on carbonation, we also looked at one of the formulas that can be used to show that chemical reaction which has taken place. Note there, when carbonic acid breaks down calcium carbonate, of which limestone is composed, into calcium bicarbonate, that is when we say carbonation has actually taken place. This calcium bicarbonate is actually soluble, and it is therefore carried away usually by rainwater. So if we had to look at a simple formula to show this particular chemical reaction, then we have calcium carbonate, which is CaCO3, plus carbonic acid, which is H2CO3, will give off the soluble calcium bicarbonate, which is Ca, in brackets, you have HCO3, then close brackets and 2 outside of that bracket. Okay, and that formula is actually for calcium carbonate plus carbonic acid giving the soluble calcium bicarbonate. Now let's look at some of the features which are actually created or formed as a result of chemical weathering, mainly under carbonation. And some of the features that we are going to look at today would be the formation of what we call a karst scenery, formation of a dough line, formation of dripstone, of which in the formation of dripstone we have stalactite and stalagmite, or stalactites and stalagmites being created. So those would be the 5 features that I would like us to look at today, and your task is going to be able to identify those features and also be able to define what those features are. Okay, I'll look at those again, the features, the karst scenery, formation of a dough line, formation of dripstone, of which from dripstone we can also identify stalactites and stalagmites. And here are some examples of some features which are created as a result of chemical weathering, especially carbonation. Okay, let's look at the first feature now, and that is of the karst scenery. What I would like you to do is, as well as looking at the feature that is going to actually be shown on the monitor or on the screen, I'd like you to also take notes, because when we go to the questions, you might need to use your notes for the completion of a couple of questions. Okay, from the screen or from the monitor here, you have a classic landscape, of which if you look at that whole landscape, that landscape is showing what we call a karst scenery. So a karst scenery is basically a landform or a landscape of which it contains some of the common features which have been created as a result of chemical weathering. So that whole landscape now is referred to as a karst scenery or a karst topography. How do we identify a karst topography or landform from any other landform features? Here are some of the common features that you can look at to tell you that this particular landform is a karst scenery or a karst topography. Okay, we start off. If you look at the feature itself, you will find that in a karst scenery, there is usually an absence of surface runoff or rivers and streams. There are not a lot of rivers or streams that are likely to be found in such a landscape or a karst scenery. Why? When rain falls, most of the water gets to be dissolved. And therefore, when the water gets to be dissolved, there is hardly any streams or rivers that are likely to be found on the surface. The rocks in this area here are actually permeable. And because they are permeable, due to chemical weathering, most of the rocks would then get to be dissolved, resulting then in absence of surface drainage or surface runoff. When I'm making reference to surface runoff, I am looking at rivers and streams and lakes, etc. In this type of scenery, it's difficult to find them on the surface because most of the water that falls here will be dissolved underground. it will not remain on the surface. So that's one of the many characteristics of what we call a karst scenery. The second characteristic is the fact that the soils which are found in this type of topography, the soils tend to be very thin. And because the soils are thin, there is also little vegetation. Okay, we're looking at soil, formation of soil. If rainwater comes in contact with the rocks here and they dissolve, then obviously there will be very little soil left on the surface. And if there is very little soil, then you would also find that vegetation is going to be little. Okay, that is another characteristic of a karst scenery. One, absence of surface runoff. Two, very thin soils, therefore there is little vegetation. Okay, number three, another characteristic of a karst scenery is the fact that there are features such as swallow holes. Okay, the swallow holes. We go back to a photograph that we looked at in our previous or the last lesson. And we looked at the gapping hills, whereby water which comes on the surface disappears into the swallow holes and they go underground. So on the surface, you can see features of what we call swallow holes also in such topography. So any water gets into the swallow holes and they disappear. Okay, when that water disappears, it then goes underground, whereby in a karst scenery, underground there are cave-ins or caves which have been formed. And those caves will contain in them underground water which runs. Whatever is on the surface gets to disappear underground through the swallow holes. Then it forms the caves or cave-ins, of which those cave-ins tend to contain stalactites and stalagmites. So caves and cave-ins in such a topography is another common feature of a karst scenery. What happens to those water that gets to disappear on the surface of a karst scenery and that goes underground? They flow as underground water and they will finally emerge somewhere else, and the emergence of that water then will form what we call resurgence. So the resurgence are like springs of which water which have disappeared on the karst topography goes into the cave-ins or caves, and it flows and it reappears out somewhere else. And the reappearing of those water then are referred to as resurgence. Note the type of rocks of such a scenery. The rocks here are mainly of Carboniferous limestone, and if the rocks are of Carboniferous limestone, this type of topography or the karst scenery is common. Any questions on the karst scenery? Okay, again, a karst topography or scenery is one which has been created as a result of chemical weathering, mainly carbonation. Some of the features which are likely to be found in such scenery are absence of surface runoff, that means absence of streams or rivers. There is very thin soil in such a scenery, therefore little vegetation, that's two. Number three, the swallow holes are common, and that is where most of the surface runoff tend to disappear into. Whatever disappears into the swallow holes forms caves or cave-ins, that's the fourth feature. Those caves or cave-ins will contain stalactites and stalagmites, the fifth feature. The water that gets to actually disappear through the swallow holes and goes underground will reappear somewhere else as resurgence. And that's feature 6 that we have looked at on a karst scenery. Any questions with that? Any questions? No questions? Okay, let's move on. This time we look at the second feature. Sorry, before we go to the second feature, you remember the swallow hole I was talking about? Okay, at the top there, somewhere at the top, through the process of solution and carbonation, that area has been actually weathered away, resulting now in water, which can fall all the way through the swallow hole down to the bottom of the cave. So the gapping hill is an example, especially the top part of it is an example of a swallow hole. Okay, the other feature that we are supposed to look at also is the formation of a dough line. So what is a dough line? A dough line is a feature which is also found in a karst scenery. And if we look at the diagram here, a dough line is simply the subsidence area on that karst scenery. And that subsidence area has been created as a result of the material at the bottom being weathered away. And when the material here have been actually weathered or washed away, then what would happen is it might create a depressed area. And the depressed area on the surface is referred to as a dough line. Okay, so if you had to do a quick sketch, you could sketch a scenery here, and then you have a depression, of which that depression that is created is showing the formation of a dough line. Note that you need to be able to say that the feature here is created where the rocks are of carboniferous limestone, similar to what we've looked at on the karst scenery. Okay, if I had to look at a definition, a simple definition to the dough line would be a funnel-shaped depression. It's simply looking at the depression on a karst scenery. It tells us there for the formation of a dough line, as the limestone is dissolved, surface material subsides and is washed into the funnel-like sand in an egg timer. But the easiest way to actually remember what a dough line is simply say that it is a funnel-shaped depression. That is what a dough line is. And you will find a dough line in a karst scenery, not anywhere else. Okay, we move on. As I've mentioned, for you to remember the dough line, simply note that it is a funnel-shaped depression caused as a result of chemical weathering, mainly in a karst scenery. Okay, the next feature that we are going to look at is the formation of dripstone. And for the formation of dripstone, stalactites and stalagmites will come in together, because a dripstone is also making reference to stalactite and stalagmites, stalactites and stalagmites. Okay, again, we are looking at a karst scenery or a karst topography for the formation of a dripstone. This feature here at the top, what do you think is the term that we can use to describing this feature here where water gets to disappear underground? Swallow hole, yes, definitely. Okay, good, we've learned something. Swallow hole here, water gets to disappear through the swallow hole, and then it will follow the cracks which are under the surface. We are looking at the formation of a dripstone now, the third feature. Water seeps slowly into joints and bedding planes under the surface. Stage 1. Then stage 2, cave are formed by the roof collapsing. So here we have the roof now tends to collapse, and the collapsing of the roofs then will form a cave underground where that feature is to be formed. Okay, when you look at the caves itself also, can you already see the teeth-like feature which has been formed? Okay, the teeth-like feature, they are now showing us the dripstone. And the dripstones, they can hang from the ceiling of the cave, or they can develop from the floor of the cave up. Okay, so you can see the drips like a teeth-like feature where the ceiling of the caves are, or where the ceiling of the cave is. Water continues to drip in the cavern or the cave, and then you can now really see clearly the different types of dripstone which have been formed. Those that are formed from the top or the ceiling down are given the name stalactite, and those that are formed from the floor of the cave up are given the name stalagmite. So the stalactites and stalagmites are dripstones. The difference between them is that one is formed from the ceiling of the cave and hangs down, and the other one is formed from the base of the cave or the floor of the cave, and it grows up like in a column or a pillar. Here we're looking at the formation of a dripstone. To discuss a little bit more on stalactites and stalagmites, of which they are to do with dripstone, the information from the monitor here says that deposits of calcite and rarely other minerals, they build up in caves by dripping water, and they are called dripstones or dripstone. Stalactite, they are icicle-like pendants of dripstone which hang from the cave of the ceiling, or the ceiling of the cave. That means from the top down. They are generally slender and often aligned along cracks in the ceiling, which act as conduits for groundwater. In other words, when we're looking at the formation of dripstones, those dripstones that hang from the ceiling of the cave down, they are given the name stalactite. Any questions so far with that information? So if you are doing or taking down notes, all you have to say is stalactites are dripstones which hang from the ceiling of the caves down. Okay, we move on. Stalagmites this time, they are dripstones also, but they are cone-shaped masses of dripstone formed on the cave floors. And you will tend to find them formed directly below the stalactites. So the stalactites are coming from the ceiling down, and directly below where the floor or the cave floor is, the stalagmites would actually build or are formed. It tells us here that splashing water precipitates calcite over a large area on the cave floor. So stalagmites are usually thicker than the stalactite above them. As a stalactite grows downward and a stalagmite grows upward, they may eventually join together to form a column. So the easiest way to remember about stalagmites are that they are also dripstones, but they form from the base of the caves and they grow upwards. The stalactites, they form from the ceiling of the caves and they grow downwards. And that's the easiest way perhaps to remember stalactites and stalagmites. Okay, we'll move on. Let's look at an example given, which is a photograph taken of an area in England showing us these features here, and they are features of stalactites. They are from the ceiling down. Here, the features from the floor up, these are examples of stalagmites. Okay, now for you to do some activities. You have 4 questions I'd like you to work on. And the 4 questions that you are going to work on will be: number 1, you explain the formation of stalactites and stalagmites. Number 2, define what a karst scenery is, or what a karst topography is. Number 3, I'd like you to explain and list some common features that are found in a karst scenery. You make a list of some of the features that we've looked at, and as much as possible, see if you can explain what they are and how they are formed. And number 4, I'd like you to define the term dowline. Okay, I'll have your attention here. Since we are actually running out of time also, what I'm going to do is those 4 questions, I would like you to actually complete them for your homework. And we are going to actually check the answers to those in our lesson tomorrow. Okay, so take note of the questions, and I'd like you to complete those activities for your homework. Bring the answers back tomorrow, and we'll go through the correction of those answers in our lesson tomorrow. Okay, class, that will also bring us to the end of the lesson. If you can stand up now, please. To the pilot teachers, our keyword for lesson 66 is carbonation. Good afternoon, and thank you, students.